Hello, geometry students. I am super excited to be starting chapter 5 with you. We are coming into the home stretch for this quarter. We have finished chapters 1, 3, and 4. Many of you probably noticed that we skipped chapter 2. The reason we did is that chapter 2 is on proofs, and proofs can be somewhat challenging for some students. And as a geometry team at Westland High School, we decided that we would like to maybe introduce proofs to you a little bit later in the semester than right at the beginning. So we are going to do kind of weave in the material on proofs in our chapter 5 unit. So we're not going to go back and do chapter 2, but we're going to bring a lot of the material that was in chapter 2 in and put it in chapter 5. So the notes we're taking today are actually just preparing us for chapter 5. So we're calling them preparation for proofs. What this is going to look like on your pacing guide is just 2 capital P's right next to each other. That stands for prep for proofs. So today's lesson is on preparing for proofs. And we've already talked about this a little bit, so I'll just kind of jump in. But the first thing we need to know when we're talking about proofs is what is a conditional statement. Can any of you remember from what we talked about earlier, what is a conditional statement? A conditional statement has an if and a then. So if it is Sunday, then I will ride my motorcycle. So the part that comes after if is our hypothesis, and the part that comes after then is our conclusion. Now what I would like you to do for your notes is I would like you to write your own if-then statement. So something true about your life. Like if I want to watch a movie, then I will go to Netflix. Or if it is Saturday, then I will play soccer with my dad, or whatever it might be. So some kind of if and a then that would be true in your life. So write that down with the word if, your phrase, then, and another phrase. I'm going to use for purposes of our discussion the one I just gave. So if it is Sunday, then I will ride my motorcycle. All right. So you can either write that sentence down if you want. It's okay to use mine. I don't know if you like riding motorcycles, but you can totally use it. Or your own. And then what we want to do is review the 2 parts. So let's go ahead and label here that the part that comes after if is your hypothesis. So we'll write down hypothesis. And the part that comes after then is your conclusion. Hypothesis and conclusion. The nickname for the hypothesis is P, and the nickname for conclusion is Q. So with a regular conditional statement, the kind of shortcut way to write this is with a little p, an arrow, and a little q. So make sure you're watching these YouTube videos on a phone or iPad or some device that will allow you to zoom. Zoom in right here and notice what it says about the statement. Conditional statement is if p, then q. Now we're going to talk about what's called the converse. Can you try to write the converse of the statement that you just wrote? So it could be your own statement or it could be mine. We did talk about what this meant in an earlier lesson. So I'll give you just a second in case you do remember. If not, I'll tell you now that converse just means to switch the order of your 2 phrases. You still keep the if and the then. So I'm still going to write an if and a then. But for example, with my statement, I would say, if I am riding my motorcycle, then it is Sunday. So I have the same phrases, but I've flipped the order. We call this if Q, then P, because we're flipping the hypothesis and conclusion. Now, sometimes converses are not true, even if the original statement is. So it is true, for example, that I often do ride my motorcycles on Sunday. But like this summer, as some of you may know, I spent 8 weeks on my motorcycle, and I rode almost every day other than when I was visiting my son in DC. I took 3 days off the bike, I think. But I was riding Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So the converse of my statement would not be true. Sometimes the converse is true and sometimes it's not. Okay, let's talk about something called the inverse. Now, inverse is where you negate your original statement, but you keep the order the same. And again, if you can zoom in on here, we put a little squiggly mark. It kind of looks like a sideways S in front of the P. This means not. And I'll go ahead and write that with an arrow. Not P, then not Q. So to negate something means to say the opposite of it. So for instance, instead of saying it, if it is Sunday, I'm going to write if it is not Sunday. So I'm doing this for my statement. You can do it from yours. You would just take the hypothesis of your original conditional statement and make it be a negative. So if instead of saying if it is Sunday, I'm saying if it is not Sunday. After the then, I also negate my conclusion. So I would say then, I will not ride my motorcycle. So that would be what's called the inverse. And that is something you're expected to know on a variety of standardized tests. All right, the last one is called contrapositive. And that I kind of like this one because it is, we're doing both of the things that we just did with converse and inverse. We're flipping the order and negating. So what do you think that would look like for the shortcut here? How would I write that? I'm going to say if not Q, then not P. So we have to negate our original phrases, but we also have to flip the order. So what I'm going to say is, if I am not riding my motorcycle, then it is not Sunday. So I flipped the order and negated. Now, the interesting thing kind of here is that the truth value of the conditional statement and the contrapositive are always the same. So if the original conditional statement is true, the contrapositive will be. The same is true with the converse and inverse. If the converse is false, the inverse will be as well. So this is just kind of, good general facts for you to know about when you're talking about proofs. All right, now, on the next part of what I want to talk to you about is something called biconditional statements. Biconditional statements. The reason why I want to talk to you about this is there's going to be a phrase that comes up a lot when you talk about math proofs and theorems in your textbook and in our notes throughout the rest of the year. There's going to be a phrase that's called if and only if. And when I first saw that, I thought somebody was making a typo, like they meant to write if but just wrote it too many times. But actually, if and only if means something very specific in math, and that's what we're going to talk about right now. So let's go ahead and write down biconditional statements. Now, bi means two, like a bicycle has two wheels and a tricycle has three. Bi always means two. Sometimes we see it in words like bisect, where it means to cut something into two pieces, so it can kind of mean a half. But in general, it means two. So what a biconditional statement is a conditional statement that can be read two ways. It can be read left to right, like we normally do, but it can also be read right to left. So let's do an example here. And this is one we used before. But if a triangle is a right triangle, then it has a 90-degree angle. Then it has a 90-degree angle. So next to that statement, go ahead and write conditional statement. I am wondering if underneath that you can write the converse. Can you write the converse of that statement? So we had if a triangle is a right triangle, that would be our P, then it has a 90-degree angle would be our Q. Try to flip the order and see what you end up with. Let's try it. The converse would be if a triangle has a 90-degree angle, then it is a right triangle. So that would be the converse. So this is something we've already learned, but let's write this in biconditional statement form. So let's write biconditional. With a biconditional, we don't have an if-then. Instead, in the middle, we have if and only if. So instead of having an if first and then a then next, we have an if and only if in the middle. Now, we put the P from our original conditional statement, so I would say a triangle is a right triangle. I would put that in front of the if and only if. So a triangle is a right triangle if and only if, then we list the Q. It has a 90-degree angle. Now, when you see a statement in this form, in biconditional form, the if and only if means that you can say out loud to yourself or in your head to yourself the original conditional statement and the converse, that it is saying both things at the same time. So if we read from left to right, we're saying if a triangle is a right triangle, then it has a 90-degree angle. But we can also read from right to left. If a triangle has a 90-degree angle, then it is a right triangle. Now, in order for a biconditional statement to be true, both the conditional statement and converse must be true. So in the one that we just read, that was a true biconditional statement. It is true that a triangle that has, when we say a triangle has a right triangle if and only if it has a 90-degree angle, that is a true statement because both the conditional statement and the converse are true. So now let's look at one more example here, and we're going to do something in biconditional form. If two lines are parallel, actually we're going to write it in conditional and converse and then biconditional. So we'll have the conditional statement is if two lines are parallel, then they do not intersect. Then they do not intersect. So that would be our regular conditional statement. Now, let's see what the converse would be. We need to flip the order. If two lines do not intersect, then they are parallel. So that would be our converse. We have a conditional statement and a converse. I'd like you to try to take a minute and see if you can write both of those statements in one sentence. So write it in biconditional form. And when we're done talking about this, we'll be done with our video notes. Okay, so with a biconditional statement, remember we want an if and only if in the middle. So I'm going to write that down. And then we'll put the P, or the hypothesis from original statement, first. So, two lines are parallel if and only if they do not intersect. Okay, so in order for the biconditional statement to be true, it must be true that the converse, the conditional statement reading from left to right and the converse reading from right to left are both true. So let's take a look at them one at a time. When we read from left to right, we're saying if two lines are parallel, they do not intersect. Is that true or false? If two lines are parallel, then they do not intersect. That would be true, so I'm going to put a capital T next to that one on my notes. All right, so the conditional statement is true. Let's look at the converse. If two lines do not intersect, then they are parallel. If two lines do not intersect, then they are parallel. So would that be true or false? Now, in order for something to be true, it has to be true all of the time, not just some of the time. Does anybody know why this statement is false? And this is a word we have not talked about a lot, but we did discuss it in chapter 3, at the beginning of chapter 3. This statement is false because skew lines, S-K-E-W, skew lines do not intersect. So when we say here, if two lines do not intersect, then they are parallel, that's false, because it could be, some of the time, that the reason the lines are not intersecting is because they're skew. So we have to write a false next to that statement. So the biconditional statement overall would be considered to be false. It is true when we read it left to right, but because it's not true when we read it from right to left, we have to call that a false biconditional statement. Okay, so that's all that we did for notes, for preparation for proofs. And what I think I'm going to have you do is we'll talk about what you need to turn in for this, but I just want to make sure that you know that these are the notes for preparation for proofs. Thanks so much, guys. Bye.